my name is Priyanka Sood and I am working as an assistant professor in Chandigarh Group of Colleges, Landra, in EC department. So today I am going to discuss about data structure and algorithms over here. So let's start with the topic. So my today's topic of concern is ADT stacks and linked list. So firstly we will discuss about what are stacks. So stacks are basically linear data structures which follows last in first out type of algorithm. It is shown in the diagram as stack of arrays, stack of plates, stack of cards also. You can see these cards are placed one after one on each other. Whenever these cards are placed on one after one, then we cannot take any card in between from this stack of cards. So for this what we need to do, we need to take out the card from the top first. Then we need to take the card which was under the top card. That means the firstly top of the card will be removed, then second top, second most, then the third most, and if we want to remove the last card, then we have to remove all of the cards which are above that particular card. Same is the case of these plates. This is the stack of plates. So if I want to take out the plate which is placed at the last position, what I need to do is I will take the topmost plate first out, then the second topmost plate out, then the third topmost plate, then the fourth topmost plate, and immediately I will go to the last plate. So this is the process which is followed in the stack. That means the plate which has been put on the stack on the top will be taken out first. We cannot take the plate which was earlier on the last position. To take out this plate, what we need to do? We need to take all of the plates one by one from the top of the stack. So the plate which is on the top is called top of the stack, and all other are actually the plates which are below the top and will be deleted one by one after the top is deleted. So basically if the top is at 5 position, whenever we take out any of the plate, it will be basically decreased, top is decreased, and top will be reduced to top minus 1. So basically in the stack, we make use of two operations. One is push operation and one is pop operation. Push operation, which is actually used to insert an element into the stack. You can see over here, this is shown as push operation in the stack. Firstly, first data element is inserted into the stack. Suppose this one is the top now. Because when one element is inserted, top will be shifted over here. When another element is shifted, top will be incremented to one position. So top will be 1 now from earlier it was 0 at 0 position. So top will be called as top is equal to top plus 1. Whenever third element is incremented, third element is added into the stack, so top is again increased, so it will follow top is equal to top plus 1. Likewise, whenever we are inserting other elements into the stack, always top increases to 1 position. So that is why we write in the algorithm as top is equal to top plus 1. That means every time we add an element into the stack, top is increased by 1 position. So this is basically push operation in the stack. And whenever we talk about deleting any element from the stack, so this is done using pop operation. So using this pop operation, whenever we delete one element of the stack, the top is almost decreased by 1 position. Suppose now at this position top is at 5. Whenever this top element is deleted, the top is decremented by 1 and top goes to top is equal to top minus 1. That means earlier it was at 5. Now it will be at 4 at this position because now this element has been deleted. So now if top is at 4 now and I want to delete this element, so while deleting this element, this top is again decremented by 1. So I will say top is equal to top minus 1. Top is at third position now. Same way, every element is deleted one after one until all of the stack is empty. So that means while deleting the elements of the stack, if we want to delete the last element which was inserted first, then what we need to do? We need to delete each and every element starting from the top of the stack. So that is why what we say that this one follows last in first out operation. That means the element which has been entered into the stack at last is deleted first only. We cannot delete the first element which was inserted at the first position into the stack at first. Firstly, we have to delete the topmost element, then second topmost element, then third topmost, and if this way we goes to the last element which is present in the stack. When all of the elements are deleted, our stack becomes empty. So basically, while deleting the elements, firstly what we need to check, we need to check whether the stack is empty or not. That means if you are deleting something and there is no element into the stack, then there is no use of operation pop. Same is the case with the operation push. If I want to delete some element, that means if I want to add some elements but the stack is already full. So firstly what we need to check whether the stack is full or not. If it is already full, then we cannot add any element into the stack. So this is basically shown as the operations of the stack: push operation, pop operation, peek operation, and stack is whether full or it is empty. Stack deletion algorithm. As we can see over here, the first thing while deleting the elements is to check whether the stack is empty. So this is written in the first step. If the stack will be empty, then we will simply write underflow and will exit from the program. But if it is not empty, that means we can proceed with the program. That means we can go through deleting the elements from the stack. So firstly, topmost element is deleted and top becomes top minus 1. Every time the element is deleted, top becomes top minus 1. So this way the stack becomes empty when we delete whole of the elements. So there is peek operation which is involved in the stack. Peek operation is basically to get the topmost element in the stack without deleting it. Pop operation deletes the element, but peek operation does not delete any element from the stack. So as I told earlier that we need to check whether the stack is full or empty while using operation delete and add. That means while using the operation push and pop. So this is the method which is used to check whether the stack is full or not. We make use of empty and we make use of full operation. The next is our linked list. Linked list is basically a list which is linked with each and every element using pointers. That means various elements of a list are attached together, that means linked together using pointers. As we know, pointers are the variables which hold the address of another variable. So in the linked list, we do have a start pointer which will point to the first element of the linked list. The first element of the linked list will be having the pointer which will point to the next element of the linked list. In this way, every element of the linked list will be having a pointer which will point to the next element of the linked list. And at the end, the linked list will be finished by using null pointer. So this is the linked list which is shown as over here. A is the first element which is having a head which is called the pointer of the list. Head is basically pointer of this list. Head is pointing to the element A and the pointer of A is pointing to the element B. Now the pointer of B is pointing to the element C and the pointer of D is pointing to the last element which is element D. At the D, the linked list has been ended. So this is represented by null pointer represented as cross. So cross shows that linked list has been ended. That is, there is no further element into the linked list. So from the linked list, we can see that there are only 4 elements in the linked list. We can have many elements into the linked list depending upon our requirement. We can add elements into the linked list. We can delete elements from the linked list. It is quite easy to add elements into the linked list and to delete them from the linked list as compared to arrays. In arrays, what we need to do, we need to shift the elements of the array if we want to insert any element in between the elements which are present earlier in the array. But in the linked list, there is no need of shifting the elements. We just take the free memory space from the free memory space is available and we will simply add that element that we want to add into the linked list into that free memory space we will link that free memory space from our elements using pointers, and we will simply add elements into the linked list. So this is shown over here, how to add element into a linked list. We can see this X is added in between A and B elements. The pointer which was earlier pointing to B is now pointing to X. The pointer of A, which is shown as dotted, which was earlier pointing to B, you can see with the red line that it is now pointing to X. And the pointer of X is now pointing to B. So that is why we can see that this element X, this space, this free memory space which is containing the element X is now added in between A and B. So now this linked list, which was earlier containing only 2 elements, is now containing 3 elements. That is A, X and B. B is the last element. It could be extended up to many elements, that depends upon our requirement. So this is the process how addition of elements is done in linked list. Now, how to delete an element from a linked list? You can see over here we have 3 elements present in this linked list. One is A, another one is X, and third one is B. So the pointer of A is pointing to the element X, and the pointer of X is pointing to the element B. So now I want to delete this element X from this linked list. So what I will do, I will simply give the address of element B to the pointer which was the pointer of A. The pointer of A, which was earlier pointing to X, is now pointing to B directly. That means this X has been deleted from the linked list. The pointer of A, which was earlier pointing to X, is now pointing to B directly, which is shown by a red line. So now this element has been deleted from the linked list, and now the linked list is containing only 2 elements, that is A and B. The linked list could be extendable, and when it ends, it is represented by the pointer null, which is represented by cross. This is doubly linked list. The linked list which we were studying earlier was singly linked list. That means only one-sided pointers were there. But in this linked list, we can see there are 2-sided pointers. One that are pointing from A to B, B to C, and other pointers which are pointing backward, that is from C to B and B to A. So this is why we say that this is doubly linked list. That means we can access the linked list from the starting, as well as we can access the linked list from the backward also. So what is the benefit of using doubly linked list while we are with singly linked list? In the doubly linked list, we can access the list from any side. If the linked list is very bigger in size, then we want to access a last element, we will start with the backward linked list. And if the element we are looking for is present at the initial stage of the linked list, we will make use of forward linked list. So this is the use of basically doubly linked list. Then there is another kind of linked list, which is circular linked list. Circular linked list means this is never-ending linked list. That means the pointer which was earlier null pointer is now pointing to the first element which was earlier represented by start pointer. Now the end pointer, the pointer of end element will point to the first element. That means there is no null pointer in this linked list. This linked list is basically circulating. That is why this is called circular linked list. In this linked list there is no null point. The end element will point to the first element, first will point to the second element will point to the third element, and third element will point to the next fourth element. So this is shown over here. This linked list is starting from the pointer list. List is pointing to the element 2. The pointer of 2 is pointing to the element 4. The pointer of 4 is pointing to the element 6. The pointer of 6 is pointing to the element 8. And the pointer of 8 is again pointing to the first element, which is element 2. So this is basically done in the circular motion. That means there is no ending point. That is why we say that this list is circular linked list. Thank you. That's all for today.